In this video, we're going to look at two-way tables and sample space. Two-way tables are a nice way of laying out two pieces of information and showing it clearly and concisely. So for example, if someone does a survey of 100 people and they were asked where they went on holiday and in which month, June, July or August. So let's put the information from our survey in a table. So we're told that in June, 6 people went to France, 18 went to Holland, and 5 went elsewhere. So we can fill those values in our table. In July, 10 people went to France, 19 went to Holland, and 2 went elsewhere. So let's pop those in our table. In August, 15 people went to France, 15 went to Holland, and 10 went elsewhere. So from this data, we can then fill in our total columns. So we've got totals of 29 that went on holiday in June, 31 that went on holiday in July, and 40 that went on holiday in August. That totals our 100 people. Along the bottom, we can then total how many people went to each country. So 31 went to France, 52 went to Holland, and 17 went elsewhere. They should also add up to our 100. We can then use this table to read from it and answer basic questions. So if we were asked how many people visited Holland in July, we would look at our table and say Holland and July, that's 19 people. Another example could be where they give you the table partially filled in and which TV channel they prefer to watch, BBC One, ITV or Channel 4. So we've got some gaps that we need to fill in here. Well, I can see that the total males in the survey was 20. 8 of them watched BBC One and 7 watched Channel 4. So adding those together gives me 15. So my missing number to go in ITV would be 5. I can then see a gap in my totals. I've got 80 people in total that were asked, and I know 20 of them were male, so I can fill in that there would be 60 females. I can then see a gap in the female row. There's 12 that watch BBC One, 28 that watch ITV, so in total that gives me 40. So the missing gap for Channel 4 would be 20. Then I can go along the bottom and fill in those totals to get 20, 33 and 27. Now both totals should add up to give me my 80. We can then also use our two-way tables to answer probability questions. So if I bring back the first table that we looked at, the 100 people that went on holiday, I can answer some probability questions from this. For example, if a person selected at random, what is the probability that they went on holiday to Holland? So I would look how many people went on holiday to Holland. Well, that's 52 people in total, out of a total of 100 that were asked. So my probability would be 52 out of 100. Another example, what's the probability that we picked someone at random and they did not visit either France or Holland? So that means they went elsewhere. So how many people went elsewhere? 17, out of a total of 100. So the probability would be 17 over 100. Now let's look at sample space diagrams. They're very closely linked to a two-way table. We use them in probability when we're doing experiments where two events are happening. The most popular one that you will see is rolling a dice and then rolling another dice and adding up the scores. So we can display all those possible outcomes with a sample space diagram. We would have dice 1 along the top, dice 2 along the side, and then we would fill in all of our values. So if I'm getting a 1 on dice 1 and a 1 on dice 2, I'm adding those scores together, so I would put 2 in that box. If I then rolled a 3 on dice 1 and a 4 on dice 2, I would add them to get 7, so I would pop 7 in that box. So let's fill in all of those possible values, and the table will look like this. I can then use this to read off some probabilities. For example, if I wanted to know the probability of scoring a 7, I would need to count how many 7s are in my table. Well, I can see that there's 6. And in total, there are 36 possibilities. So that means the probability of scoring a 7 would be 6 out of 36, which of course we could simplify to 1 over 6. But we don't necessarily have to when it comes to probability. Another example would be the probability of scoring a 5. So I can count how many 5s are in my table. There's 4. So this one would be 4 out of 36, which would simplify to 1 over 9. Finally, if I wanted to know the probability of scoring a number less than 5, I would just need to count how many numbers in my table are less than 5. So that could be 4, 3, or 2. So in total, there's 3 4s, 2 3s, and 1 2. So that's 6 in total, out of 36. So again, we could simplify to 1 over 6. A second example of a sample space diagram that's slightly different would be to show an experiment where we flip a coin and we roll a dice. So we've got 2 different options here. We could get heads and tails, or we could get the numbers 1 to 6. So we could show it in a table like this. To fill it in, I would just say heads 1, so H1, H2, H3, all the way to 6. And then tails 1, tails 2, all the way to 6. So this shows all those possible outcomes for flipping a coin and rolling a dice. So again, we can find the probabilities from this. So what's the probability of getting heads and a 3? Well, in my table, there's only one way of getting heads and a 3, but there are 12 options in total, so it will be 1 out of 12. Another example, what's the probability of getting tails and an even number? So we've got tails 2, tails 4, and tails 6. So that's 3 options, out of a total of 12, which of course we can simplify to a quarter.